Our topic is the empirical and molecular formulas. The empirical formula is a chemical formula that gives only the relative number of atoms of each type in a molecule. Two things that should be known about empirical formulas is that subscripts in these formulas are the smallest possible whole number ratios. And once you have the molecular formula, it's simple to find the empirical formula.
An example of the empirical formula that we came up with was a compound containing nitrogen and oxygen is decomposed in the laboratory. It produces 24.5 grams of nitrogen and 70.0 grams of oxygen. Calculate the empirical formula of the compound.
So the first thing you're going to do is write down the given, which is 24.5 grams nitrogen and 70.0 grams oxygen. The second part is to write down the masses of each element present in a sample of the compound. If you are given the mass percent composition, calculate the masses of each element from the given percentages. And that's going to be 24.5 grams nitrogen times 1 mole nitrogen divided by 14.01 grams nitrogen equals 1.75 mole nitrogen. Step 3 is going to be to convert each of the masses to moles by using the appropriate molar mass for each element as a conversion factor. So that's going to be 70.0 grams oxygen times 1 mole divided by 16.00 grams oxygen equals 4.38 moles oxygen. And then the last step is going to be to write down the elements using the number of moles in each element as subscripts. So nitrogen subscript is going to be 1.75 and oxygen is going to be 4.38.
So next you're going to want to divide all the subscripts in the formula by the smallest subscript. So it's going to be nitrogen and 1.75 divided by 1.75, and then oxygen 4.38 divided by 1.75, and then you're going to get N1 oxygen 2.5. And then the final step is if the subscripts by a small whole number, 2 in this case, to get whole number subscripts. And that's going to be nitrogen 1 and then oxygen 2.5 times 2, and then your answer is going to be nitrogen 2 and then oxygen 5.
An example for the molecular formula of butene, C4H8, shows that each freely existing molecule of butene contains 4 atoms of carbon and 8 atoms of hydrogen. Its empirical formula is CH2.
Our topic is the empirical and molecular formula. The molecular formula is a chemical formula that indicates the actual numbers and types of atoms in a molecule. This is called a molecular formula. Molecular formulas are used in chemistry, especially organic chemistry.
An example of the molecular formula that we came up with was photosynthesis. Photosynthesis is 6 CO2 plus 6 H2O plus light energy produces C6H12O6 plus 6 O2.
Glucose is 40.0% carbon, hydrogen is 6.72%, and oxygen is 53.3% off. If the molar mass of glucose is 180.18 grams per mole. What is the empirical molecular formula? In this example, we need to find the molecular formula of glucose. But in order to find that, we must first find the empirical formula.
The first thing you need to do is write down the given, which is 40.0 grams of carbon times 1 mole of carbon divided by 12.01 grams of carbon, which equals 3.330 moles of carbon. Next is 6.72 grams of hydrogen times 1 mole of hydrogen divided by 1.01 grams of hydrogen, which equals 6.653 moles of hydrogen. Then 53.3 grams of oxygen times 1 mole oxygen divided by 16 grams of oxygen, which gives you 3.3310. Next, you have to divide the smallest variable, which is 3.330, by all the elements. So, which gives us 1 mole of carbon, 2 moles of hydrogen, and 1 mole of oxygen. Finally, the empirical formula is C1H2O1.
So you have to find the molecular formula using the empirical formula. Remember that the molar mass of the molecular formula divided by molar mass of empirical formula gives you the molecular formula variable. So since you have CH2O, we are going to break apart the elements and add them together. So we have C plus 2H plus O. Oh, yeah. And then we plug in the molar mass, which is 12.01 for carbon plus 2 times 1.01 for hydrogen plus 16.00 for oxygen. Overall gives us 30.08 grams per mole. Next, we divide the molecular formula by the empirical formula, which is 180.18 grams per mole divided by 30.03 grams per mole, which gives us 6. We go back to the empirical formula, CH2O, and multiply that by the molecular formula variable, which gives us C times C, I said that again? No, I didn't, sorry, it's okay. C times CH2O, which overall gives us C6H12O6.
Real-life application for the empirical formula. To help describe the ratio of each type of atom in the substance, the smallest possible whole number ratio. Chemical formula that gives us Chemical formula that gives only the relative number of atoms. An example is the molecular formula of glucose, C6H12O6, shows that freely existing molecules of glucose contain 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. Its empirical formula is C2HO. Example of the molecular formula that we came up with.
Wait, time out. Sorry.
What? Produces C6H12O6 plus 6O2O.
Glucose is 40.0% carbon, 6.72% hydrogen, 53.3, oh my god.
Percent oxygen.
Okay, next we have to find the molecular formula. Okay, sorry.